Good day, young learners. I am Gilbert F. Lopez, a BSc3 major in mathematics student from Northern Mindanao Colleges Incorporated. For today's video tutorial, I will be discussing evaluating algebraic expressions. So let's have a review first. So let us take back our memories, especially on the rules of integers, the basic arithmetic operations, and even exponential notations, and also some components of an algebraic expressions. So let's have first algebraic expression. So by the way, what is algebraic expression? So algebraic expression is a combination of terms by the operations such as addition, subtraction, multiplication, division, and etc. So let us have an example. So this one, 10x cubed plus y minus 2. So this is an example of an algebraic expressions or expression. What are the components of an algebraic expression? So algebraic expressions have components which is constant, the variable, and the coefficient. So constant is any real number. So example, 5, 6, 3, 23, and pi. So pi is considered constant because it has an approximate value of 3.1415. So what is variable? Variables is any letters used to represent numbers that are not known. So any alphabet or any letter from alphabet. So example, X, Y, Z, D, S, T. So coefficient. Coefficient is the numerical factor of a monomial. So example, 4x. So 4 is the coefficient. So let us now proceed with operation on integers. So in integers or integer rules for addition and subtraction, always remember in addition and subtraction, if it has the same sign, add and then take the sign. If they are in different signs, subtract and take the sign of the largest absolute value. So we have an example here. So in addition, if they are in the same sign, so take the sign. If they are in different signs, so subtract and take the sign of the largest absolute value. So in subtraction, to subtract an integer from another integers, the sign of the number which is to be subtracted should be changed, and then this number with the change sign should be added to the first number. So this one. So you have to subtract and change the number or the sign of that particular number. In operation of integers for multiplication and division, if they are in the same sign, the answer is positive. So if they have in different sign, the answer will be negative. So always remember that. So let us not forget those basic arithmetic operations and rules of integers. here let us review exponential notation. So there are some components also of an exponential notation. So they are the base, exponents, and power. So base are a given number that is being multiplied. So exponent tell how many times the base is used as a factor. Power is the product of the equal factors. So we have here an example. So 3 squared. So 3 is our base, 2 is our exponent, and the product of that particular number is 9. So that is our power. So another example, 7 cubed. So 7 is our base, the exponent is 3, and the product is 343. So we also have exponential notations. So by the way, this is a sort of review. So here we have some example of exponential notation. So x a squared b cubed. Another 4x squared or 4 squared x cubed y to the 4th. Next is quantity of negative 3 squared. And last is negative 3 squared. So in this example of exponential notation, how will we use or write it in an expanded notation? So here 6a squared b cubed, since 6 has no exponent, so you have to write it once. Then our a has a power of 2, or it is being raised to the power of 2, so you have to write it twice or 2 times. Then our b cubed, so b is raised to the power of 3, so we have to write it in 3 times. So this one. So how about 4 squared x cubed y to the 4th? So since 4 is raised to the power of 2, then we write it twice. Then x cubed, so x is being raised to cube, so you have to write it 3 times. So this one. And the last is y to the 4th, so you have to write it 4 times. So in this number 3, so the quantity of negative 3 squared. So how we are going to write this one? So multiply negative 3 by itself. Remember, if we see a term which is enclosed by a parenthesis, so this one, parenthesis, so it means they are in the same group. So they are in the same so they are in the same term. So if that enclosed term was raised to a specific exponent, multiply it by the required given exponent. So in this example, we write, or the required was raised to the power of 2. So then you have to multiply it by negative 3 by itself. So the result is, so negative 3, or the quantity of negative 3 times the quantity of negative 3. So here, 3, negative 3 squared. So how we are going to write this one? So this is different from this example, the quantity of negative 3 squared. So that is different from this one. So negative 3 squared. How we are going to write this one? So take note, if does not have a parenthesis or it was not enclosed with a parenthesis, so it means only 3. Only this one, only that one will be multiplied by itself. Do not include this sign, the negative one. So always remember that. So that negative sign was placed before the number, so only the 3, 1 will be multiplied by itself. So our answer will be, so this one, only this one, only this one, so the 3, 1, so you have to multiply 3. Do not include this sign. So always remember, if it's, or if there's no parenthesis inclusion, so do not multiply it by itself. So let us now proceed with our main topic, which is evaluating algebraic expression. What is meant by evaluating algebraic expression? So evaluating algebraic expression means to replace, take note, to replace a variable by a particular value to simplify the expression. So always remember to replace a variable. So the other one, we evaluate an expression by substituting. So when you replace a variable, it means you do substitution. So the value of the variable and finding the value of the expression. So let's have some examples. For example, so evaluate the following. So remember that our variables, the value is given, so don't be confused of that, because our variable has given a specific value. So number 1, 7x. So when x is equals to 5, so take note that our variables are given. So all you have to do is copy this one, the 7, and substitute the value of our x, which is 5. So always remember that when the coefficient and the variables, when the coefficient and this variable are in the same term, it simply means you have to multiply it. So 7 times 5, so it gives us an answer of 35. So let's have another example. So 6ab, when a is equals to 2, b is equal to negative 3. So what we are going to do, so copy 6a, or copy 6, negative 6, then replace or substitute the value of our variable. So the value of our a is 2 and the value of our b is negative 3. So what we are going next, so next is multiply this one. So negative 6 times 2, or you can also multiply this one because it has in the same term, so it doesn't matter. So because it comes up with the same result if you do this, or if you multiply this first or this one, the 2 and the negative 3, it comes up with the same result. So I have here, or I multiply here this one, sorry, I first multiply this one. So this one, the negative 6, the negative 6 and the positive 2, it becomes negative 12. So the remaining is negative 3. So since they are in the same term, so you have to multiply this. So negative 12 times negative 3, it gives us an answer of positive 36. So if you remember the rules of integers, so if they are in the same, or if you multiply the same sign, so the answer would be positive. So let's try let's have another example. So here we have an operation, or the operation of our expression is in two terms. So this one. So this one term, and the second term. So our expression is 4pq minus 7p, when p is equal to 2 and q is equal to 5. So copy the given 4, then replace the value of our variables, the p and q. So copy the 4, this one, 4, then replace or substitute the value of our p and q. So our p is 2 and our q is 5. Then minus the second term, minus 7 times the value of our p. So what we are going next, so multiply. So 2 times 5, I multiply this one first. So this one, so this term, so 2 times 5 becomes 10, then copy 4 because it is given. So minus 7 2 or times 2, so it becomes negative 14 rather. So 4 times 10 becomes 40 minus 14. So if you remember our rules in integers for subtraction or addition, so you have to, so in the rules of our integers, you have to copy the largest sign of our value of this. So copy the largest absolute value. So since 40 is the largest one, so 40 minus 14, so becomes positive 26. Another example. So 4x minus 2yz plus 6xy when x is equal to 2, y is equal to negative 5, and z is equal to 3. So this expression is in trinomial because it has 3 terms, or it is in 3 terms. So the same procedure, so you have to substitute all the values of our variables. So if you know that this one, so you can directly, so the next step is you have to simplify. So you can simplify by terms. So I have here, so I simplify it by terms. So 4 times 2, 8, then solve it first here. So negative 5 times 3 becomes negative 15. So the remaining is 2 there, the negative 2, plus 6 times 2 times negative 5 becomes negative 10 because it has a different sign. Then this one, negative 2 times negative 15 becomes positive 30. So 6 times negative 10, since they are in different terms by the rule of multiplication of integers, so it gives us an answer of negative 60. So first is you have to add, so 8 plus 30 becomes 38 minus 60. So it gives us an answer of negative 22. last example. So evaluate the expression if a is equal to 2/3 and y is equal to 1/2. So all the values of our variables are in fraction. So here 3, our given expression is 3xy cubed. So what we are going to do, so copy 3 because it's given. So substitute the value of our variable. So the value of our x is 2/3, the value of our y is 1/2. Then simplify. So first this one, because you have to solve first if there's an exponent, so solve it first. So 1/2 cube, or quantity of 1/2 cube, it gives us an answer of positive 1/8. So 3 times 2/3, so 3 times 2, 6 over 3 times 1/8. Therefore 6 over 3 times 1/8. So you can cancel this one. So 6 over 3. So 6 divided 3 becomes 2 times 1/8. So 2 times 1 is 2 over 8. So our answer is 2 over 8. Or simply as, you can reduce it by dividing both numerator and denominator by 2. So 2 divided 2 is 1. 8 divided 2 is 4. So it gives us an answer of positive 1/4. Always remember, in evaluating algebraic expression, so first is identify the variable and its given value. Number 2 is replace or substitute the given value of the variables in the expression. And number 3 is simplify the expressions using the order of operation and the rule of integers. And also don't forget to analyze the given expression, because you will not be confused if you are going to understand what is the given expression. So I think that's all for today's video. I hope you have learned a lot from my tutorial. Thank you and God bless.